What's up, everybody? Welcome back. So, yesterday we covered um, the introduction section of the Foundations course for Odin Project. And today, I'm going to dive a little bit deeper. Sorry. Having completed how this course will work, introduction to web development, motivation and mindset, asking for help, and join the community. These are all very soft skill focused, informational, nothing really we got takeaway. There's no hands on keyboard aside from creating your GitHub account, which we did live on stream yesterday. So today we're going to get into the prereqs. Let's get into the first section called computer basics. Oops, I just checked it like it was complete. Sorry. All right. Introduction. Spend most of your time on a computer, hence understand how to work with your computer is crucial. This section contains general overview of topics you will learn in this lesson. Software and hardware, how to take screenshots, importance of strong passwords, assignment. Goodwill Community Foundation resources are excellent to get you acquainted with the basics. All right. Without being condescending, we're going to still go through this. All right. Just to make sure everyone's on the same page. They're not going to spend an hour on it, but we're going to make sure that we understand the high level bullet points. So they go through hardware versus software, different types of computers. Oh, they go really basic. Okay. Yeah, we're going to skip this because the assumption is if you already know this, you're not going to dive too deep into it. So, PCs versus Macs. Okay, they go really deep in there into like beginner level. Okay. What's an operating system? Again, we're going to just look at it just to make sure everyone's on the same page. Manages, excuse me, memory and processes, as well as all the software and hardware. Allows you to communicate with the computer without knowing how to speak the computer's language. Without the operating system, the computer is useless. Useless, I say. What's an application? Program, application, app. App is type of software allows you to perform a specific task. Okay, so they kind of went through like the three layers here, right? Like not layers, but like the start off. They're talking more about what a computer is. Within a computer, there's an operating system running. Within the operating system, there's applications that run. I think everyone's on the same page. Open source versus closed source software. Almost every piece of software is created using source code, which is a technical blueprint that tells a program how to function. When creators release their finished product to the public, they must decide whether to make its code open source or closed. Closed is proprietary. Proprietary? Yeah, proprietary. Open source, open to the public, right? Available to anybody who wants it. Which is more common? Yeah, apps, games, software, usually closed. That's where the money is, right? Open source, usually free, public collaboration. May not be as user friendly, right? Because it's going to be bulky. They're not worried about bells and whistles. Closed source, more likely to be stable, focused product, and easier to access. What the hell just happened there? The customer support often costs money. Yep. Taking screenshots. I wonder why they made a tutorial about this, but okay. Like they made a whole tutorial about this. Why? Okay. It's all good. I honestly don't know how to do that in Ubuntu, but I'll Google it. I obviously know how to do it in Windows and in my smartphone. Strong passwords, battery horse staple, right? If you know the XY, what's it? XKCD, where they talk about a strong password can just be like three unrelated nouns, and that's stronger than doing like a you know uppercase word with like four numbers after it or something like that. I'm good here. I know how to create a strong password, which things to avoid. Battery horse staple. Okay, so I'm good on that section. Knowledge check. Is Windows an operating system or an application? We know that that's an operating system. What's the difference between open source and closed source? Open source code available to the public, free usually. Closed source, a lot more polished. Proprietary, costs money. Use cases of a screenshot. I mean, I use it if I need to show anybody something from my computer, right? The way it's being presented to me, I'm going to take a snapshot of that. A weak password, lowercase password 1234. How about that? Additional resources are available here. We're not going to do those. We're going to mark this as completed. And next lesson. All right. How does the web work? Okay. Before you can understand how to program the web, you need a more rigorous understanding of the web itself than you likely have now. These concepts provide a more holistic understanding of the ecosystem in which you'll be working and will enable you read to talk intelligently with other developers about your work. Yeah, this should be a good one, hopefully. This section contains a general overview of topics that you will learn in this lesson. What is the internet? What are packets? And how are they used to transfer data? Understand the difference between a web page, a web server, and a web browser, and a search engine. What's a client? What's a server? What's an IP address? What's a DNS server? So I have like pretty basic knowledge of these things. I think it would still be of value to go through them though, okay? Overview of how the internet works. How long is this video? Let's see though, before we jump in there. I'd like to see a DNS request in action. It's an ad. Okay, here we go. 4 minutes, yeah. That's awesome. All right, so that explained a little bit of the packet concept of when you make a request and something comes back to you. I want to read about how one part of the web interacts with the other, read about watch DNS request and act. I wanted to see this one. Mm. Okay, I think that's good enough for that one. Names get translated into IP addresses using several checks. This is your knowledge check. What's a web server? What's a network? What is the internet? IP address, router, ISP, internet service provider. What are packets and how are they used to transform data? What's a client? What's a server? Web page, web browser, search engine, DNS request. Which browser are you currently using? We're on Chrome. And in your own words, explain what happens when you run a search on google.com. Okay. Helpful links to other content isn't required, so consider it supplemental. Listen to part 1. Security Now podcast, How the Web Works series. Watch a packet's journey. Consider buying the book Tubes. Behind the scenes at the end. That reminds you of series of tubes. If you're old enough to understand that reference. Explore how fiber optics use light to transmit data over long distances. Okay, I'm going to mark that one done. Let's quickly take a look and see how we're progressing on this one, by the way. Paths, resume. Oops, all paths, view. Okay, third one, installation overview. Okay. Having the right tools. For us, that means setting up a development environment for writing good code. Installation plan. In the following sections, we'll go over the steps for setting up your environment. No need to install anything in this lesson. This is an informational lesson. Informative, I should say. These sections are the most important steps in the entire curriculum, so we can't mess that up. Take the extra time, double check what you're typing, or you may cause more headaches for yourself down the road. Okay, installing a supported operating system. We did that. We did a virtual machine running Ubuntu. Installing Google Chrome as your web browser. Did that. We're on it right now. Installing a code editor. We didn't do that yet. I think it's going to be VS Code though. Creating an SSH key, a personal password that will identify you to GitHub, Heroku, and many other sites you'll be using. Okay, we didn't do that yet either. At the end of the next lesson, you'll be up and running with many of the tools you need to write and run code. It may seem like a lot of steps, but we'll get through it as painlessly as possible together. If anything goes wrong, remember to use these steps. Examine the terminal output for the actual error. Google, Google, Google. Never be afraid to ask for help. Okay, so we went with our Linux Ubuntu, right? And we did that on a virtual machine that's running right now. Okay, so we did that. Not concerned because we already did it. Is that the only thing that was covered in this one? I guess so. Okay. Gonna mark this sucker as completed and move on. And then if you're already using Mac OS Ubuntu or an official flavor of Ubuntu as your operating system and have Google Chrome installed, you can skip this section. Okay. Mark that as done. We're breezing through this thing today. Okay. All right, text editor. Text editor is by far the most used developer tool, regardless of what type of developer you are. A good text editor can help you write better code with real-time code checking, syntax highlighting, and automatic formatting. Why can't I use Microsoft Word? Well, rich text editors such as Microsoft Word and LibreOffice Writer, which is like open source version of Word, are great for writing a paper, but the features that make them good at creating nicely formatted documents make them unsuitable for writing code. Yeah. You may have seen, like, let's say you're thinking about like a coding scene in a Hollywood movie, right? You can tell if it's bullshit or not. Like if it looks too fancy, it's probably not using any type of actual code editor. Um, you can think of code editors as specialized web development tools. They're highly customizable and offer many features that'll make your life easier. Nothing worse than spending 2 hours trying to figure out why your program isn't working, only to realize you missed a closing bracket. Yeah, closing bracket, quotes, all those kind of things. Not enough spaces if you're using Python. Plugins, syntax highlighting, auto closing of brackets and braces. Ooh, I didn't know that. And linting are just a few of the benefits of using a code editor. There are many text editors out there to choose from, but we suggest starting with Visual Studio Code. VS Code, hell yeah. I've used that before, it's great. VS Code, as it's commonly referred to, is an excellent free code editor. Excellent add-on support and great Git integration. Okay, let's get into VS Code installation then. Download VS Code. Open your terminal. Sorry, I know that font looks a little small. I don't know if I can make that bigger. I cannot. So I'll just read along as I'm typing. Or actually, I'll copy and paste. Run the following command to download the latest VS Code. So copy this whole thing. And I lost my terminal. Here it is. And boop. Oh, what happened? What happened? Let's try that again. What did I type wrong here? Now why would that not work? I think I had too many characters in that first one. Let's try that again. There we go. Yep. Talk about syntax, right? Okay, did that. Enter the following command in your terminal to install it. Sudo or sudo, depending on who you ask, is like your admin mode permission to say do this thing because I'm an admin. If it doesn't have that sudo before or after it, your machine will be like, no, you didn't say Simon Says. So now we're going to install and enter my password. If prompted, enter your password. You might see a notice starting with download is performed on Sandbox. You don't need to worry about that. Delete the installer file. We'll do that after this is done. Yep, unsandbox thing came up. Remove code latest.deb. You can start VS Code in two ways. Click on the VS Code from the applications menu or use code command from the terminal. Ooh. Oh, fancy. I like that. I like that. Okay. Definitely go dark mode first of all. I think I can exit terminal now. Before I do, let me see if I can do a joint window here. Yeah, I can. Perfect. Okay, so I open VS Code. Okay, mark it complete. Our VS Code is here. I think we should watch, let's see this tutorial and see if it's of value or not, okay? It's going to be 22 minutes for this particular video, and I want to absorb it from whatever documentation's inside of the Odin project, instead of getting the list of features from that video. Okay, command line basics. Let's kill this VS Code session. Let's expand that. Feeling scared of the command line. Yeah, I think I am. I was very familiar with the command line in the DOS days, though, and I was very comfortable with that. Man, this mouse is really jumpy. Here we go. Hacking the mainframe. Okay. Talk about the command line interface being that black screen that you see during those Hollywood movies during hacking scenes. Okay. Base of operations from which we can launch other programs and interact with them, like we did with code. We typed in code and it brought up VSCode. You learn how to navigate around your computer and how to manipulate files and directories, also known as folders. We know that. Okay, let's test drive it. So on Linux, the command to get to your terminal is Control-Alt-T. Boom, there's your terminal. Excuse me. Before we do anything, take a look at the following text. $, who am I? This is a terminal command because it begins with a $sign. The $sign saying, hey, enter what follows in your terminal. This means that we must exclude the $sign when entering any command. In the example above, we would only enter who am I? LawnFatherrr. This is a common indicator, so make sure that you aren't entering $sign before a command. Now that you're aware of what $sign does, make your terminal for a test. Take your terminal for a test run. Yep, we did it, and it returns our username, LawnFatherrr, right here. A little hard to see, but right there. Let's see if I can make the there we go. View, zoom in. Let's do a few clicks. There we go. LawnFatherrr. Okay. Why learn this now? You've been making heavy use of the command line throughout the curriculum. In the upcoming installations project, we'll need you to install many different software programs using the command line. Additionally, you'll primarily be using Git within the command line. More on this later. As part of the bigger picture, you may well be using the command line on a daily basis in your career as a software developer, making it an indispensable skill in your toolset. Lesson overview. Describe what the command line is, open it, use it to navigate directories and display directory content. Got it. Create a new directory and a new file. Rename or destroy a directory in a file, and then use it to open a file or folder in a program. Okay. Okay, we got the following lessons. Setup. Follow instructions in download files section only. Is all you need as you have the required software already. Introducing the shell. Navigating files and directories. Working with files and directories and pipes and filters. Okay. So let me just scan through here real quickly. Okay. So let's start off with visiting the Unix shell course. Okay, no dark mode, huh? Can you default it to dark mode, I wonder? No, that's the theme for Chrome. Blah. I need it to be like the theme for the sites that I visit. I don't know if it'll do anything though. Like the site itself has to be in dark theme, I think. Alright, we'll bear with it. Okay, introducing the shell. Let's zoom in a little bit on this guy here. Will it let us? Yes, it will. Okay. Shell is a program where users can type commands. With the shell, it's possible to invoke complicated programs like climate modeling software or simple commands that create an empty directory with one line of code. Most popular Unix shell is Bash. Born Again shell. I didn't know that. So called because it's derived from a shell written by Stephen Bourne. Bash is the default shell on most modern implementations of Unix and in most packages that provide Unix-like tools for Windows. Using the shell will take some effort, some time to learn. GUI presents you with choices to select. CLI choices are not automatically presented to you. So we must learn. Small number of words gets you a long way, and we'll cover those essentials few today. Cool. When the shell is first open, you're presented with a prompt indicating that the shell is waiting for you. Let's bring up the shell here. Yep. Shell typically uses $sign as a prompt, but may use a different symbol. In the example for this lesson, we'll show the prompt as a $sign. Cool. Prompt is followed by a text cursor, a character that indicates a position. Yeah, we know that. Let's try our first command. ls is for short for listing. ls. Cool. There's all the folders in on my desktop. All right. Nell Nemo, a marine biologist, has returned from a 6-month journey, a survey of the North Pacific gyre. I don't know what that is. She's been sampling gelatinous marine life. She has 1,520 samples that she runs through an assay machine to measure the relative abundance of 300 proteins. She needs to run these through an imaginary program called goostats.sh that she inherited. Top of this huge stat, she has to write up results by the end of the month. Bad news is she has to run goostats by hand using a GUI. She'll have to select and open up a file 1,520 times. If goostats takes 30 seconds, that's 12 hours. Next few lessons will explore ways Nell can achieve this. More specifically, they can explain how she can use command shell to run the program using loops to automate the repetitive steps of entering file names so that her computer can work while she writes her paper. Okay. So you need to know how to navigate to a file directory, create a directory, check the length of a file, chain commands together, retrieve a set of files, iterate over files, and run a shell script containing her pipeline. Dang. Are they gonna walk us through that, or we just gotta do that? What the hell? Hold on. Sorry. They're like, all right, well, have a great day. Like, is there like something to click here for next steps? Or like, is the arrow supposed to take me somewhere? Let's see. I guess so. Okay. Okay. Got it. About 40 minutes in right now. On Nell's computer, the file system looks like this. There's, oops, scroll up here. First, let's find out where we are running by running a command called find out where we are by, okay, I got you, which stands for print working directory. That tells you where you are right now. Okay. On Linux, it'll look like /home/Nell. Got it. So if we do that, print working directory tells me we're at home/LawnFatherrr. Okay, that's what the file system looks like on Nell's computer. Top of, oh my god, the scrolling just sucks. At the top of is the root directory that holds everything else. Refer to this as a slash character. Using a slash character on its own. This character is the leading slash in the user slash Nell. Okay, got it. Inside directory are several other directories like bin. Built-in programs are stored. Data, users, and temp. We know that our current working directory, users slash Nell, is stored inside users because users is the first part of its name, of course. Similarly, we know that users is stored inside the root directory because there's a slash at the beginning. Okay. Underneath users, we find one directory for each one. Okay. And again, we use ls as our listing command. So we learned two things so far. pwd, the working directory that you're in right now, and then ls for listing. Got it. Okay, what's going on here? ls prints the names of the files and directories in the current directory. We can make it output more comprehensible by using the -f option, which tells ls to classify the output by adding a marker to a file and directory names to indicate what they are. A trailing slash indicates that it's a directory, @ indicates it's a link, star indicates executable. Okay, so let's try that. ls -f. And now we see a bunch of these trailing slashes. No stars and no ats. We do have this random file here. I should delete that when I get a chance. Okay. If it gets too cluttered, you can clear. That's cool. Okay. Clear that terminal. ls has lots of other options. There are two common ways to find out how to use a command. You can do --help. We can read its manual with man, such as, okay, so the manual for ls can pop up if you put man ls. Man ls. Here's all the manual that comes with it. Okay, how do you exit this though? Q? Yeah. Okay. You can do ls --help, and you'll see this huge list of things that will be like optional, um, like variables you can add onto there. If you try to use an option that is not supported, like -j, it'll just tell you. Okay, that makes sense too. Man command, we got that one done. You can list in particular orders. Okay. Like -t by time of last change, -r in reverse order. Cool. So if I said ls -f of desktop, which is a folder, the output would be shell lesson data. Okay, not only can we use ls in the current working directory, we can use it to list the contents of a different directory. Okay, that's why it showed this thing, because it's what's in this here. Okay. And then when she listed the contents of the shell lesson data, you saw two more subfolders within there. And I think this was the one that they were looking for, right, in the example. Okay, let's say we want to move to the data directory we saw above. Then you change directory to desktop, change directory to shell, and then change directory to exercise data. You do a pwd to find out where you are and tells you you're here. You do a listing -f, and it shows you all the folders within that exercise data. And I'm guessing you're going to be looking for like numbers.txt, by the way. Change directory into the shell lesson data. If you want to go up the directory tree. Yeah, that doesn't work. You don't just change directory back up to the one you came from. You do cd change directory ... and that'll take you back up. I think DOS had a similar command on that. You do a pwd check, it tells you where you are. Now they put a -a. What does the -a do? The special directory ... doesn't usually show up when you run ls. If we want to display it, you put a -a. Got it. That's why it's here, and it wasn't showing up before. Show all. That's what it stands for. Cool. Why'd they put a regular cd here? What does that do? So pwd, ls, and cd. Those are three basics right there. What's my current location? What's a listing of everything in here? And how to change directory. Got it. Explore some variations on those commands. What happens if you just type cd on its own? Let's check cd. Nothing happens. Can you check what happened? pwd gives us the answer. I'm guessing it just takes you back to root, yeah. Turns out the cd without an argument will return you to your home directory. Cool. Okay, so far so good. They're changing directory into that one particular one that we saw before. Using the file diagram below. If pwd displays that you're in users and thing, what will ls -f backup display? That should display 2012, 2013, 20 this thing. So I think it'll be 3 because you put the -f, so it's going to show the slashes after that. I think. Let's see. Solution. Oopsie. There is a directory. Wait, what just happened? Oh, I'm an idiot. I said users things where we were, and it said ls ... slash backup. I should have looked at this backup, and that's why it would display these things. Darn it. It tricked me. That's what it would display right there. Very good job there, tricking me. Okay, using file system diagram below, if pwd displays users slash backup. Pwd says you're here, and -r tells ls to display things in reverse order. What command will result in the following output of sub final original? Sub final original. Would it be ls pwd? No. ls -r -f or ls -f -r -f users backup. Since you're already there, it says you're already in users backup. I think it's going to be B. Yes. Oh, both of them. You can be explicit or without arguments, but the first one would not work. Okay, cool. Good to know. We now have encountered commands, options, and arguments, but it's perhaps useful to formalize some terminology. Consider the command below as a general example of a command, which we'll dissect to its component parts. So the $sign is your prompt, ls is your command, -f is your option. Oh, I thought that was an argument. Okay. And then blue is your argument. The slash is your argument. Didn't know that, because I would always call that argument. Okay. So if you were in moved to desktop shell lesson data, and then you did ls -s to sort exercise data, then the output would be 28 total, and you'd see 4 animal counts, 4 creatures, 12 numbers text, 4 protein, 4 writing. Sizes returned are in blocks, as these are defined differently for different operating systems, so you may not obtain the same figures as an example, okay? Then ls-f/ will just give you those folders that are in the application. Organizing files, you'd say list this particular folder. This nor command, list nor, oh, okay, so when you hit tab, it'll know that you're talking about North Pacific. It's like just faster, efficient typing. Cool. Tab completion. Okay. Okay. I think I'm gonna need to pause right here now. It's been 53 minutes. Got a lot of good content out of the way. And let's go back to see how we did. Yeah, so we got through a lot of the basic stuff. We're now learning about command line, and then we're going to set up Git, which I think will take up the next stream. So I think we should good time to stop now, and then I'll get this uploaded onto YouTube. If anybody's watching down the road as a recording, hope you're enjoying this. Give me some feedback, like and subscribe. Hopefully we can continue this series and start getting some good hands-on keyboard traction too. Cool. Everybody have a wonderful rest of your night. See you later.